Hi, this is our presentation, AISI 1020 Steel, with Emily, Nick, Sid, and I'm David. AISI 1020 is a standard grade carbon steel. It is composed of 0.7 to 0.23% weight carbon, 0.30 to 0.60 weight percent manganese, 0.04 weight percent maximum phosphorus, 0.05 weight percent maximum sulfur, and the base metal is iron of 99.1 to 99.5 weight percent. The typical elastic modulus of carbon steels at room temperature, 25 degrees Celsius, ranges from 205 to 215 gigapascals. The typical density of carbon steels is about 7.85 grams per centimeters cubed. This typical tensile strength varies between 355 and 435 megapascals. The wide range of ultimate tensile strength is largely due to different heat treatment conditions. Also, it has a Rockwell B hardness of 28, and the elongation is 0.28 to 0.43%. AISI 1020 steels are used in simple structural applications, like nuts and bolts, as in the picture to the top right. They are known for their flexible machinability that encompasses good strength and high ductility. These steels are often used in engineering and construction applications, including automobile parts and gears. The picture to the bottom left is of a ball bearing, and the one on the right is a carabiner.
As far as the economics are concerned, typical AISI 1020 stock steel is seen to cost about 60 cents per kilogram, making it one of the most affordable steels in the market. Among the most common shapes available as stock are steel balls, sheet metal, bars, and coil stock. The AISI 1020 steel is preferred in industry for its good weldability, machinability, as well as good balance between strength and ductility, making it one of the most forgiving steels to work with. However, due to the low yield strength of the steel, poor dent resistance is observed as one limitation in the various fabrication processes such as sheet metal forming. Furthermore, 1020 steel is highly susceptible to corrosion. In order to prevent corrosion, techniques such as painting, plating the product surfaces, as well as altering the atmospheric conditions such as humidity should be considered.
1020 steels are typically formed by melting down scrap metal. Because it's a low alloy steel, impurity control is most important. Having too much oxygen in steel can cause carbon monoxide to form during solidification, resulting in blowholes in the solidified steel. It can also lead to oxide inclusions, which negatively affect the properties of the steel. Unwanted oxygen can be removed by adding aluminum or silicon to the melt. These elements react with oxygen to form alumina or silica, which then float to the top and are absorbed by the slag. They can then be skimmed away. Phosphorus makes steel very brittle, so it's also undesirable. Phosphorus will typically react with oxygen, forming oxides in the melt. To remove these oxides, calcium oxide, which is also known as quicklime, can be added to the furnace. The quicklime reacts with the phosphorus oxides to form calcium silicate or calcium phosphate. These products then rise to the top of the melt and can be skimmed away. Sulfur is typically present in the melt as ferrous sulfide. Sulfur can be removed at the beginning of the process by adding magnesium to form magnesium sulfide, which rises to the top and can be skimmed away. If sulfur is present later in the process, it is generally removed by reacting with calcium oxide to form calcium sulfide and iron oxide. For this reaction to be successful, the slag must contain a high amount of calcium oxide and a low amount of iron oxide. A common processing technique for 1020 steel is forging, which is illustrated on the right. Hot and cold working are also commonly used in the form of either drawing or rolling. 1020 steels are also commonly machined. Additionally, 1020 steel has exceptionally good weldability.
The weldability of a material refers to its ability to be welded. Most steels can be welded, but some are easier to weld than others. A material's weldability is used to determine the welding process and to compare the final weld quality to other materials. Weldability can be determined using an equation from the American Welding Society. The weldability of 1020 steel has been calculated and equals 0.275. The chart on the bottom right shows that 1020 steel is excellent for welding. 1020 steel can be strengthened using a typical method of heating to around 1600 degrees Fahrenheit, quenching in water, and tempering to relieve residual stresses and improve toughness. Case hardening using carburizing can also be used to improve the surface hardness while maintaining a tough interior. Annealing at a high temperature can also be used to improve the mechanical properties. Thanks for watching!